All right, everybody, so this is the second day video for section 6. Again, all about absolute value, equations and inequalities. So we're starting today, and we got a pretty short day, but looking at this one here, what we have that we didn't have on the previous video is absolute value set equal to absolute value. And when that's the case, you just consider it a special situation and you're going to handle it the same way every time, and we've got that defined for you down below here. So again, whenever we've got absolute value equal to absolute value, just like yesterday, two cases. So the first case is whatever's inside absolute value equal to whatever's inside other absolute value. Always connect with the word or, okay, or union, and then pay close attention to this. The second writing or second case goes like this. It is, again, whatever is inside the absolute value from one of them, in this case the left one, equal to the opposite of whatever was inside. So there's that negative sign there. A lot of times you'll have to write parentheses if you've got more than one term inside the absolute value. And so that's what it looks like. So again, now that we've done it once, to kind of paraphrase it, absolute value equal to absolute value goes like this. Two cases. Whatever's inside equal to whatever's inside. Don't change a thing. Just basically take away the absolute value. Or in between. Then absolute value, whatever's inside on the left, keep it identical. So notice that these two are identical. So you could think of keeping the left side the same every time. The right side is where it's different. So on the first case there, we kept the right side just like it was. In the second case, you negate it by putting a negative sign out in front of whatever is inside. And if there's more than one term, you wrap it in parentheses and you distribute and go from there. So we're going to work through that together, and you'll get the hang of it. So here you see an example of what we were talking about. Absolute value equal to absolute value. So two cases. First case over here on the left, whatever's inside the absolute value equal to whatever's inside the other absolute value. Connect it with the word or. Then, whatever's inside the left side absolute value, keep it exactly the same, equal to, and then negate or put a negative on the right side absolute value expression. All right, so now I've got the rest of it worked out for us here. So you're just going to solve. So here we would go ahead and solve that left side where we would subtract 3r from both sides, or we could subtract 3r from both sides and then add 1. So we get r equals 6. And then over on that right-hand side, just be a little bit careful here. You need to remember to distribute, and I'll model that. So notice that that negative is distributed like so. So negative 3r right there, and happens to be negative 5 right there. Okay, so we end up now with that equation that's relatively easy to solve. I'll just unveil that right there. So we end up with those two solutions, like we were getting two solutions in a lot of the ones yesterday, and then you go ahead and graph it. So again, either go back and re-listen to this one more time if you need to, pause it and kind of look it over if you need to, or if you're good to go, let's move forward together here. All right, example 6. Two-parter, so we've got a couple here to do, but it says special cases, so notice that. So that just kind of puts us on alert, and we do have to always kind of look out for certain things here. So this is special cases of absolute value equations. All right, so now what we see here is that in part A, we've got the absolute value of 6x plus 7 is equal to negative 5. But remember, absolute value means distance from 0, and we never talk about a distance of a number from 0 being negative. Therefore, if we ever have absolute value equal to a negative number, we simply say no solution. Right? So it's really easy, very short work. Don't even have to write everything I did. You just have to catch it. So that's one of those special cases. Okay, special case on the right-hand side. It's different than the left one, but it's still a special case because now we're saying the absolute value is equal to 0. Well, that means the distance of our number from 0 is 0. In other words, that's basically telling us, and it's our job to catch this, if the absolute value is ever equal to 0, then the only way that's possible is if that thing inside there is actually equal to 0. So the way you handle that is simply set that equal to 0, and then you just got to solve that. So I'll walk that down a little bit. Okay, again, you don't need to write it all out. I just wrote that for you as kind of a mental note. But whatever's inside absolute value equal to 0, solve it, get x equals 12, then we're good. So two special cases, always kind of got to have your eyes on the lookout when you're dealing with absolute value. If it's ever equal to a negative, no solution. If it's ever equal to 0, one solution only. Okay? All right, and then we've got some special cases of absolute value inequalities, and we'll talk about those, okay? So now, in A, we see absolute value, and we see it associated with a negative number. So we might be inclined to think that there's no solution here, but in this particular case, it's saying, when will the absolute value of our number be greater than -1? And since absolute value is always positive, that means absolute value of x, no matter what x is always going to be bigger than -1, because it's always going to be positive. Therefore, in that special case, we don't say no solution, we say everything would work there. In other words, if you look back at that original there and you stuck a -11 in where that x is, it would say the absolute value of -11. The absolute value of -11 is 11. And since 11 is indeed greater than -1, it means -11 is a solution. So again, in other words, it means everything works. So we say all real numbers, or if we want to use integral notation, we say -infinity to infinity. Okay? B, I've got some smiley faces down here just because I like them, but also because it's reminded me to do a little, at least one step on each of these before we can kind of get working on them. So on this one, just like we've worked with on the past, we see absolute value, but we see it's not isolated. So the first thing we're going to do here is add 2 to both sides before we even think about what we're dealing with. So now it reads absolute value of t minus 10 is less than or equal to, we're going to add 2 to both sides so we get a -1, okay? Now, up on A, when it was absolute value is greater than -1, that's all the time. But here in B, when it says absolute value of something is less than or equal to -1, well, it's never going to be negative. And so this is that case where we look at it and say, no solution, all right? And absolute value will never equal a negative. It will never be less than a negative, all right? Down below, I think it might be the last one here. It's a pretty short day here. But absolute value is less than or equal to 0. Okay, so let's think about that. Absolute value of something will never be less than 0. All right, so if it just said absolute value is less than 0, we'd say no solution. But this is saying, when will the absolute value of this particular number or expression be less than or equal to 0? It will never be less than 0, but it could be equal to 0. So in this case, even though it is an inequality to begin with, because it says less than or equal to, what we're going to do is simply rewrite it and say the only thing it could be is the 0, and the only way it can be 0 is if what's inside actually equals 0. So in that particular special case, you would just write it equal to 0, and now you're going to solve it. So you're going to do what? Subtract 2 from both sides, so x is equal to -2 in that scenario. All right, again, pause it, look it over, digest it, re-listen if you have to. Otherwise, let's see if maybe we're done here today. Yep, that's it. All right, all done. Short one today again. Good luck on your homework.